All right, good morning, everyone. So today we're going to work our new form. Our new form is called the point slope form. That's in the point slope form, okay? And in a point slope form, one cool thing is that, guess what we need? We just need a point and a slope to set this up. That's a review on what we've covered before. So far, we covered something called standard form. In standard form, we take our x and y and we always put them on the same side. ax plus by equals to some number c, okay? Where x and y's are on the same side. One cool thing is that you can find the intercepts, x and y intercepts, fast. Okay? Well, an example of this, if I say 3x plus 4y equals to 12, what is the x-intercept and what's the y-intercept? Hopefully you remember that to find the x-intercept, I make y0. So to find the x-intercept, you make y equals to 0, right? And to find the x-intercept, to find the x-intercept, you make the y0. And to find the y-intercept, you make the x0, right? And when we do that, you can do that by writing this on your notebook and then using your finger and just cover it up. If I just cover up the y's, isn't 3 times 4? 3 times 4 is my x-intercept. If I cover up the y's, if I cover up the x's now to solve for the y-intercept, 4 times 3 is my x-intercept. Okay. I'll write that out for you guys in case you want to see that. If I'm solving for the x-intercept, 3x plus 4 make the y 0. So 3x equals to 4 times 0 is 0. We're left with 12. And then we can divide 3 to both sides. X equals to 4. Of course, you can do this mental math. The more we practice, the faster we'll be at this. So this will actually be less work. If I solve for the y-intercept, we make the x 0. 3 times 0 plus 4y equals to 12. 4y equals to 12 because the 3 times 0 is 0. So divide 4 to both sides. Again, we're using every skill we learned straight from week 1. Y is 3. The cool thing here is that then I can graph it. The x-intercept in left and right, the horizontal direction, 1, 2, 3, 4 is going to be 4. The y-intercept, 1, 2, 3 in the vertical direction is a 3. This is my y-intercept, that's my x-intercept. Then we have the line. We sure did do a lot of writing, but you could do all this in mental math. Our second problem was second style of writing a formula of a line was our slope-intercept form. And we learned in our last class that I can change standard form into slope-intercept form. So let's actually do this with this example. I want to convert this to slope-intercept form, which is y equals to mx plus b. And the key thing is that, for this one, is that y is by itself. For standard form, x and y are on the same side, but for slope-intercept form, y is by itself. So let's get y by itself. To get y by itself, we want to get rid of the 4 and the 3x. We said if we're solving for the variable, you want to get rid of what's farthest away, and that's 3x here. So we get rid of 3x first, and then we get rid of 4. So minus 3x to both sides, minus 3x. We see that 12 and negative 3x are not like terms, so we write them separately. Now, how to get rid of 4? We divide everyone by 4. If you practice this in IXL, you're probably pretty darn good at it now. Y is equal to negative 3 over 4x plus 3. If you want to raise in your allowance, write this equation, write this problem, and go show your parents. Say, hey, Mom, look what I can do. They'll be like, wow, that's pretty impressive. Okay, now that we have this form, we have special terms, the letter M and B. They stand for the slope and the y-intercept. And again, these are hints of how to graph this line. So I don't have to plug in a table, x is 1, x is 2, x is 3. So my slope was -3/4, and the y-intercept was +3. Again, this is my m, and this is my b. So the y-intercept says, hey, where do I start? And we have the y-intercept again, just like before. And the slope gives us the directions, rise over run, how to get to my next point. So from this bus stop, or from this point, what are my directions to get to my next point? Well, the directions are -3/4. So go down 3 and to the right, +4. Down 1, 2, 3, run 1, 2, 3, 4. Put a dot. So graphing these lines is a skill. I'm giving you an equation. You have to create a visual representation of that equation in the form of a line. And a lot of things in algebra is looking at the equation and translating that to a graph. So we can look at that, look at the trend. All right, so these are our two main forms. And then now today we're going to work on point slope form. Okay, so we need a point. We're going to call this x1, y1. That's our point. And we're going to call slope m, which is another rise over run. Okay, so two things that we covered before. We covered a point. We'll call it x1, y1. We don't need x2, y2 because there's only one point here. And the form for us is y minus y1 equals to m, x minus x1. Okay. There's a parentheses because I'm going to multiply the slope by x and x1. So just to advise you that y1 and x1, sorry, the x and the y here are like every x and y in all our three equations. Let's go back and take a look. We have a x and y in this form. These are x and y. We also have a x and y over here. X and y, right? So all these problems have x and y because we need an input and an output value. And the x1 and y1, that's the point that we would use here. That's our point that we're going to plug in. Oh, this K showed up. Okay, so that's our x and y. So let me give you an example of what this would look like. If I give you a problem, y plus, not let's do y minus 2 equals to 1/3 x minus 1. So looking at this for the first time, this might look a little bit, what? How am I supposed to graph that? Well, if we know this is the form, point slope form, and you can notice that y's are on one side, x's are inside the parentheses, and there's a slope multiplying them. There's really three parts to this. We can tell that the point is x and y. Here's my x1 and my y1. So that's going to be 1, 2. You might say, Mr. Go, but they're both negative. You know what? But that's how we're set up with. We're set up with, oh, darn it, negative sign. There's a little mark here. Oops. Well, I can undo that. Oh, delete the whole thing. Oh, almost. Okay, so we have our form y, let me write it, y minus y1 equals to m, x minus x1. Okay. And here is our slope. which is 1 over 3. So if you look at the original problem, they're already negative. So if they're negative, the negative is, you can almost say it's cemented to the ground, it's locked in there. So the y value is just a 2. The negative here for the x, that's cemented in the ground. So the x value is positive 1. Now we can rewrite this. We can rewrite this into the form. If I tell you the point is x is 1, let's write y minus equals to parentheses x minus, and we're just going to fill in the blank. The blank here is a y1, which is a 2. The slope m here is going to be a 1/3, and the x1 is going to be a 1. And you see that the negatives, which are already there, make the problem negative. Now, why do people like this form? Well, first thing, if you can, again, just like slope-intercept form, figure out what the characteristics are, what is the point and the slope, we can graph this in literally, again, 10 seconds. So what is the point we're given? 1, 2. 1 in the x, 2 in the y. So pay attention here. I put x is 1, y is 2. Make sure you are, again, taking notes. If you think you're learning by just watching, math is not a spectator sport. You've heard that before. And if you're probably failing my class, it's maybe because you're not taking notes. So 1, 2. So then the slope here tells me what's my journey, what are my directions to my next point. The rise over the run. And the rise is positive 1. So we're going to go up 1 space. And the run is positive 3. 1, 2, 3. This is our line. So here we go. Let's write another one. If I say y is equal to, not y is equal to, y minus 5 is equal to negative 2 over 3, x plus 1. So the goal of us to right now is to say, hey, that is not standard form. X and y are not the same side. This is not slope-intercept form because it's not y equals 2. And that looks like our new form, what we call point-slope form. And you can identify that I have my y and x here. So let's write that out. What is your point? And what is your slope? So the point, x1, y1, is not 5, 1. That would be 100% wrong. Remember, it's y minus, this is actually a y. Over here, that's actually an x. So the x is negative 1, and the y is positive 5. And that looks kind of contrary to what we see here. But remember, the form starts off as y minus y1, so the negative is already there, equals to m x minus x1. The negative is already there. So what made it into a positive is because it was a negative 1. x1 was a negative 1. The slope here is negative 2 over 3. So let's go ahead and graph it. X is negative 1. Y is 5, 1, 2, 3, 4, 5. Put a dot. That is a point for sure we know on this line. The slope is negative 2 over 3. So we rise negative 2. So it means we go down by 2 steps. And we run by 3 steps. Positive 3. 1, 2, 3. Let's do this again. Our point, actually no, let's review. Our point is negative 1, 5. Yep, that looks like 5 and negative 1. And from that point, from that stop, the graph follows the slope, negative 2, down 2, and over 3. Let's do this again. Y minus 4 equals to negative 3 over 4 x plus 2. Okay, why don't you guys right now tell me what my point is? Tell me what my slope is. Y minus y1 equals to m, x minus x1. How are you going to remember that? Practice. There's different ways of practicing though. You can either just write this like standards, you can just say it in your head, repeat it to yourself, and some of you guys might need to create flashcards. Remember, it's really up to you. You're learning how you learn, what you need. We're all different. Thank you. There you go. Our x value, remember, that's a x minus, right? So that has to be a negative 2 to make it a positive 2. The y is going to be a positive 4. Now, some people think of it as this way. What would cancel out a negative 4? Well, a positive 4 would. What would cancel out a positive 2? A negative 2, right? So some people think of it that way instead. Not a problem, Paula. And then our slope is negative 3 over 4. Great, we have all the directions we need to graph. Negative 1, 2, 1, 2, 3, 4. The idea here is that we don't always have to graph from the y-intercept. We can graph from any point. From that point, we can then follow the directions, the slope. Negative 1, 2, 3, and positive 1, 2, 3, 4. Okay, now we're going to go backwards and we're going to give you a graph and then you're going to tell me the equation of that graph. And then we're going to do that through IXL. Okay, on IXL today, you guys are going to be asked to do these problems. And look, the setup is already given to us. And they told us the point, x1, y1, they told us the point, and they told us the slope, which is m. And our format, again, is y minus y1 equals to m, x minus x1. So as long as we plug in the x and the y in the right position, and we plug in the m, we're just helping us set up the problem. The line includes a point and a slope. What's the equation in point-slope form? So all you have to do is copy the x and y value and the slope in. That is the setup of this problem. So my y is negative 10. My m is negative 1 over 8. And my x is 1. Right? We're just plugging them in, writing the equation now. My point and my slope. That's why I call this point-slope form. Because you can write an equation from any point on the graph and the slope. No, easy, right? Okay, let's gonna make this skip to the next level. This one still the same, except now you have to write it yourself. Okay? They said write the equation in point-slope form. Okay, so in point-slope form. So in point-slope form, y minus y1 equals to m, x minus x1. And just write that. It takes you 5 seconds to write it. x1, y1, m, that's my slope. So now we know the parts, so we're not going to mix things up. We're not going to flip it around. So y minus y1, which is 1, equals to 1 over 6, x minus 10. Again, I'm just plugging in the x and y values. We've learned 3 different styles writing the same exact type of equations, line equations. And each of them have the pros and cons, right? Everyone has their pros and cons, and each of them have different characteristics. Okay, let's go ahead and write this. So we're going to write y minus y, which is 1, equals, then we're going to do a fraction. Can't see it. Fraction. We're going to write 1 over 6. Open up another parentheses. And we're going to write x minus 10. Okay, you guys have filled out IXL prompts before? Brilliant, thank you. Now, here is a problem. The point 7, 4, and 5, 3 fall on a particular line. What is the equation of point slope form? Now for this one, they gave us a point, but they didn't give us a slope. Fine, we can come up with a slope ourselves. Do you guys remember what the slope equation is? It's rise over run, but there's a way of doing it with 2 points. M is equal to rise over run, and this was y2 minus y1 over x2 minus x1. Simply, what was the rise between these points? How did I get from 4 to 3? Did we go up or down from 4 to 3? You could say the rise was -1, right? How did I get from 7 to 5? Did we go forward or backwards? We went back by 2 spaces. You can do that without the formula, but the formula is easy for a lot of people. Let's call this x1, y1, x2, y2. 3 minus 4, because that's y2 minus y1, over 5 minus 7, x2 minus x1. And this gives us our -1 over -2, which reduces to become 1/2. Well, now we know the slope. Now, which point do you want to use? It actually doesn't matter. You pick whichever point you want. If I write y minus 4 is equal to 1/2 x minus 7, notice I use the 7 and the 4 for this problem. This would be 100% correct. If I instead use the other 5, 3, y minus 3 is equal to 1/2 x minus 5. Using 5, 3, this would also be 100% correct answer. As long as you give me a point and a slope. I don't care which point you give me. Now, why is that true? Let's go ahead and graph this. We'll do a little tight graph here. We're going to say 1, 2, 3, 4, 5, 6, 7. That's 1 point. And then we're just going to follow the slope. The slope is rise over run. Rise up 1, run 2. Okay, that's my line. Whoops, I didn't do the 4. What's wrong with me? I'm sorry. I just wrote 7. And then up 1, 2, 3, 4. And our rise is up 1, run 2. Something like that. But let's look at the other point. 5, 3. 1, 2, 3, 4, 5. Here's 5. Here's 7. Here's 4. Here's 3. 5, 3. Hey, isn't that on the line already? And what's the slope of this line? Same slope. Rise 1, run 2. What happens is, regardless of which point you start on, you're still talking about the same line. It's like a bus. If you hop on a bus on National or hop on it on Overland, if it's the same Metro bus, it's the same bus. You're just hopping on at different stops. Right? And a bus stop has a lot of stops. Our bus line has a lot of stops. Has a lot of stops along the way. Okay, a lot of stops along the way. So whichever equation you use, one of these two, they're both representing the same line. And if we simplify that, we would actually get that out. We'll see that. Okay, so it doesn't matter which one you're going to plug in. Our slope was 1/2. So y minus 4, is equal to we're going to use the numbers. We said 1/2, right? And then x minus 7, because that's our x and y. Don't mess up the order. All right. So we're going to work on those 2 skills. And the last one, I want to go back. Okay, so we're given a graph, and we're asked to write the point-slope form. And now, again, I might say this is one of the easiest, but this is one of the easiest ways of writing an equation. We just have to look for 2 things, a point and a slope. Now, we get a choice, which easy point you want to use. So I'm zooming in here so you guys can see what point looks like it's going to be easy. That looks like an easy point. That looks like an easy point. So we have a couple of choices here. They gave us a dot right here in red. See that in red? So I'm going to use that point. But we actually have a lot of choices here. So we use that point. The point is going to be 10, 6. So I'll write that down, 10, 6. Now, what is the slope to get from this red point to the next easy point along the line? Now, you can pick any of these points, 1, 2, or 3, and it'll give you the same slope once we reduce. So let's go on a journey. How do I get from red to 3? We have to go rise over run. So rise would be -1, -1. I'm going to run back 1, 2, 3, 4, 5, 6. So the slope is -1 over -6, which is 1 over 6. And now this slope describes every change in the graph. So let's actually go to point 1 and let's see if that's going to work out. From point 1 to point 2, if I rise 1 and I run 1, 2, 3, 4, 5, 6, yeah, that gets us the next point. Let's do the next one from 2 to 3. Rise 1, run 1, 2, 3, 4, 5, 6. Oh my gosh, this slope is the same thing for the whole graph. Rise 1 and run 1, 2, 3, 4, 5, 6. Yes, this slope is the same thing for the whole graph. So these are the points they want me to use. Let's go ahead and write that in our equation to solve this. They want us to write something in point-slope form. And since I wrote the slope, I know the slope is 1 over 6, positive 1 over 6, because they're reduced. It didn't reduce, it's simplified. And our y is a 6 and our x is a 10. So there are different modalities here. We're looking at the graph, we're writing the equation, we're looking at 2 points. So there's different ways of solving these problems. Not always going to be the easiest, sure. Okay, so let's go ahead and do the next problem. Okay, they gave us a dot, so let's use that dot. Let's use the dot they gave us. Now let's go find some other points that are easy. That looks like an easy point. This looks like an easy point. There's a couple of them here. Right? So let's look for our point. We said the point is that looks like a number 5 and -5. So our x and y point is 5, -5. Careful, it's always x first then y. That's what we call an ordered pair. It's an ordered pair. And then what's the slope? How do I get from the red point, let's call this to point 1. How do I get from red to 1? The rise is -1. So, sorry, +1, because we went up, and then back 1, 2, 3, 4, 5. So +1 and -5. So the slope, which is rise over run, we're saying is rise 1 and back 5. Well, what if I want to go to point 2 here instead? Would that be the same slope? So to get from red, that was red before, right? To get from red to 2, we go down 1. That means that's a -1. But the run is +1, 2, 3, 4, 5. So we're just counting like kindergarten kids. So don't freak out about it. Just make sure you got the rise and run correct. Now, is 1 over -5 the same as negative 1 over 5? We learned before that the negative can go on top or bottom, but you can only use it once. You can also write that negative sign in the middle. So we have everything we need to write our point-slope form. We have our point, and we have our slope. We have everything we need. Y minus y, which is a negative 5, equals to slope negative 1 over 5, parentheses, don't forget the parentheses, x minus 5. Let's do one more. Okay. This is our y value. If you want, you could write y plus 5 instead, because negative is a positive. Okay, we can always simplify that. Let's do one more. Oh, we're in challenge zone already. What? That's pretty fast. Okay, we'll take their point. Don't overthink it. Looks like a big value, but let's write out the point. The point is, that looks like 10. Every tick mark is a 10. That's going to be 30. Our point is x is 10, y is 30. We have our point. Yay! Halfway there. Now we have to find the slope. Now, remember the slope. Look for nice points. This looks like a nice point. Up here looks like a nice point. So how to get from red to 1 or to 2? It's up to you. But because they're both going to give us the same slope in the end. I like going up. It seems easier for me. So the rise to get to point 1, it's 1, 2, 3, 4, 5, 6. So the slope is rise over run. Remember the letter M is slope for us. The rise is, we said 6, I think. 1, 2, 3, 4, 5, 6. And the run, I take one step over, 6 over 1. What if I go to 2 instead? I would go down negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. Negative 6 over back one step, that's a negative 1. Yeah, that still reduces or simplifies to become 6 over 1, or just 6. Well, now we have everything we need. Y minus y, which is 30, is equal to m, which is 6, x minus x1, which is 10. We have everything we need. Okay, so with a little bit of practice, you guys will do great. There's 3 IXLs today. None of them are going to be extremely difficult, but we need to practice so we're great at point slope form. I think we'll stop here. Let me talk after I stop recording.